Hello, and welcome to Beyond the Gates. I'm Annette Kirkland. This season, we're talking about 7 Labs, 1 ERDC. Discover the power of ERDC's 7 laboratories as they bring their technical expertise to solve the nation's toughest challenges, from developing technologies that support the warfighter to improving the civil work systems we rely on each day. See how each of these 7 labs play a unique role in engineering a safer, better world. This morning, I have with me 2 guests, Dr. Austin Davis, he's a technical director, and Sarah Eckley, communication specialist for the Geospatial Research Laboratory, otherwise known as GRL. Good morning.
Hi, good morning.
Good morning.
How are y'all this morning?
Doing well. How about yourself?
Doing great. I'm so glad you guys are on the show this morning. And we're going to start off with my favorite question. Could you tell me about yourselves, your background, and explain your roles at GRL?
Yeah, so I'll start off. I'm Sarah Eckley, and I've been a part of ERDC for nearly 12 years now. I feel like I blinked, and here we are over a decade later. My journey here actually began during my college days as a Pathways program intern. So I would spend a lot of my school breaks working here at GRL, gaining hands-on experience and a lot of just civil service type of knowledge. And after graduating with my degree in communications and a minor in leadership and dance from Christopher Newport University, I transitioned into a more permanent role here at GRL and have since grown through various positions over the years. And it's ultimately led me to my most recent appointment as the Strategic Communications Officer. And kind of in simple terms, for my mission of this role is just to ensure I get the right information to the right people at the right time, and all while supporting our incredible researchers here as well as our senior leadership.
Okay. And we've worked together a lot over the years.
Yes, we have, through that communications PAO type of hat. And so you know what it's like when you wear different hats and different roles.
Absolutely. Okay, great. Dr. Davis?
Yeah, good morning. So I'm Austin Davis. I suppose, probably like many of your listeners, I was very curious about the world as a kid, and, that led to a career in geoscience and remote sensing. And these technologies and these technical disciplines are cool because they help us identify, patterns in landscape and help us, make maps that are important and help us understand the world and, how things work. I suspect many of us can also relate to that feeling of being lost and, not knowing where you are. And, I remember as a kid, those times where it's like, oh, you go on a road trip before, all the digital maps existed and, have to print out your MapQuest directions and things. But, having that map can be, really helpful. And, I think in the modern era, we have all these digital maps and, all these kinds of analytics that help us understand more and more about places and terrain and, make unfamiliar places more familiar to us. And that, I think, is really the value that, geospatial science and sort of the profession that I've been in, really provide. And, these 2 themes of, bringing scientists and soldiers together and also, using maps to, understand more about the world, really, I think, highlight, a lot of, my career. So originally I'm from Clinton, Mississippi, so right down the road there from Vicksburg.
Austin, I did not know that.
Yeah,
Okay.
I went to Mississippi State.
Okay.
I've been, really fortunate to have great mentors at ERDC, and I've grown my career first in the environmental lab, then the geotechnical and structures lab, and then, now finally at GRL, I guess almost 16 years later, where I'm the current technical director. And so in my current role, I oversee the program of the lab, the products that our research staff make that really provide the true contributions that the lab is capable of. And then also many of our strategic partnerships. Sarah helps, with that as well, and we work together on that. So yeah, it's been a really cool place to be so far.
Great. Just a side note, my husband and I were on a trip this past weekend, and we talked about the whole map thing because I remember as a kid trying to help my parents, turn here. I was so bad at reading a map. It was terrible. So, we're all very, so used to now something telling us where to go and what to do. So,
Yeah.
so for our listeners who might not be familiar with your lab, how would you describe the overall mission of GRL?
Yeah, so I'll take this one. I would say the bottom line for the overall mission is GRL is here to innovate solutions to give our soldiers the best possible, situational awareness for the battlefield, but also we solve problems for our nation too. So I'd like to think of our researchers here as just like the ultimate map people, but they just go so far beyond roads and rivers, and they characterize both physical terrain as well as social and cultural environment of a battlefield. So, for example, if a military unit is deploying, they need to know everything about that environment.
Right.
And the researchers here, they develop, the methods and whatnot to measure and analyze all of that data so our soldiers can make fast, accurate decisions. And what's also really cool is we don't just do strictly overseas combat operation, assistance. We also have a lot of civil works efforts that we do alongside USACE. So GRL applies that exact same cutting edge spatial analysis to support environmental protection initiatives as well as disaster response. And I know we'll probably get into that later on in this discussion, but that same technology is also what helps squads to, navigate foreign terrain, can also help emergency responders and do hurricane damage here at home on our home front.
Great. So GRL, if in case anyone doesn't know this, is located in Alexandria, Virginia, with the Army Geospatial Center. How does this unique footprint help GRL act as a bridge between ERDC's 7 labs and the broader Army intelligence and engineering communities?
Yeah, so I can take this one. I guess it's important to really recognize that, when it comes to map making and providing, this ability to have situational awareness, that's a force-wide activity that has to span the whole scope of the Army. It's not just for, one soldier or a small group or just one part of the Army. And when you think about like how large the Army is and its diversity of missions and activities and things it's asked to do, being able to provide the right map that has, current information captured in it, because the landscape's always changing a little bit, sometimes a lot in a short period of time, and making sure we can reflect those changes, is important. And so when we talk about, what geospatial is, we're talking about that idea, most of the time of, this understanding of place and how different things, relate to each other sort of, on the landscape. And if we get that right, if soldiers can get that right and they can be provided the tools that they need to get that right, it really underpins all kinds of decision making. It enables geointelligence, understanding specific features and, are they hostile or not? It can help with construction planning and, where it might make sense to, place a structure or not place a structure. How we as an Army move over terrain or, place artillery on that terrain, and how we fight and how we, assist folks in that, humanitarian assistance that Sarah just mentioned. So being co-located here with the Army Geospatial Center is important because they really represent that, more operational, reach back support for a lot of these capabilities, both on the warfighter support side and then also, the way the Army procures technology. Army Geospatial Center embeds a lot of subject matter experts in what we call, capability program executives, which are the different organizations in the Army that, procure new technology and field those things to soldiers. And so as a group, holistically, we work together to make sure our soldiers have the best, understanding of, wherever they're being asked to go in the world, because it's often said the Army fights an away game. We're not fighting here at home. And so making sure that they understand these faraway places, like it's their own backyard is super critical. And the technologies that we're delivering are really the bedrock for how they're able to do that.
Right, exactly. So, next question. The theme of our show this season is discovering the power of ERDC's 7 labs, united to solve challenges. Can you provide an example of how GRL has partnered with another ERDC lab to tackle a challenge that neither could have solved alone?
Yeah, so cross-laboratory collaboration with ERDC is huge, and I would imagine every other lab would agree with that. So specifically integrating GRL's geospatial capabilities with other labs has definitely been a fundamental driver of our multidimensional science discovery, I would say. So breaking down those research silos has allowed a lot of our investigators and PMs to fuse our spatial intelligence with other science materials, environmental modeling, structural engineering to solve a lot of the complex challenges at the foundational level. So a lot of that stuff, we've also started with like our basic research collaboration among labs, and just working alongside our sister labs has definitely been able to, quite simply, it sounds cheesy, but like we're stronger together,
It's not cheesy because it's true.
Yeah, I feel like what we bring to the table is so important, but we also need our sister labs to fill out the rest of the table and kind of make that a more well-rounded, successful way to solve our challenges. So another example is GRL has worked alongside EL, CREL, CHL, Thurl to tackle a massive multi-million-dollar maintenance headache of our dams and levees, using a technology called the Relief Well Sustainment Deployable Resilient Installation Water Purification and Treatment System. Try saying that a couple times fast.
Is there an acronym for that?
So RWS.
Okay. There you go. I figured there's an acronym. There's an acronym with everything. So
you know what? Absolutely. And sometimes they mean different things, which can get a little confusing. But,
exactly.
Yeah. So, but GRL would not have been able to solve this without the other labs. And so they were able to completely re-image a system. So instead of hauling toxic chemicals, the drip system generates its own high-strength, gas-fused bleach right on site using nothing but simple table water or table salt and water.
Mm-hmm.
So by combining GRL's tactical, deployable engineering with other labs with world-class expertise, we've been able to solve a maintenance problem, creating, safer, cheaper, and a greener way to protect our nation's critical infrastructure. So these are just a couple of examples, but I'm sure Austin probably has other ones as well of just cross-laboratory efforts that have been able to be carried out, and it's because of our diverse expertise here at ERDC with our other labs that we've been able to succeed with that.
Exactly. So a key pillar of ERDC's mission is geospatial engineering. How does GRL use terrain analysis and mapping to give our soldiers an edge, and why is this so important?
So, I think if we think about what geospatial engineering is, in the Army, it's a very small. It's done by a very small number of soldiers that are known as geospatial engineers, geospatial engineering technicians. They're mostly NCOs, some warrant officers as well, and yet, it represents a small portion of the Corps of Engineers as a part of the Army. And yet, those few soldiers are responsible for providing, that map and that understanding of, what the landscape looks like, what the terrain is, what the risks on that terrain are to support any type of mission or operation. They're responsible for that, not just, for the engineers, but for the entire force, for the maneuver force, for protection planning, for, intelligence, for fires, all kinds of different activities. And then, the Army is, the nation's, land domain force. But, being able to provide that map, across all the services for our combatant commands, that's really, and our partners as well, making sure that we can connect and have interoperability with our allies when it comes to understanding where things are is super critical. And that's really, I think, the role that geospatial engineering plays. And through that, our force is, made more lethal because they understand where they are. It makes it safer because, they can identify threats and, position, resources and people more effectively on those landscapes, and just overall make, better decisions.
Right. So important. But one of the toughest challenges facing our military today is operating in GPS denied environments. So why is that such a problem, and what is GRL doing about it?
Yeah, I think that's a really critical question right now. So GPS is such a strategic national asset, and if you lose GPS, you're kind of screwed. You lose your operational dominance, and so that's kind of where GRL is stepping in for that. And their approach is pretty brilliant. So because GPS relies on a vulnerable radio frequency, GRL is developing solutions that use a visual terrain mapping instead. So, for example, GRL has created a software that runs directly on the standard issue smartphone. So soldiers they already carry that. So if GPS goes down, a soldier can just use the camera's the phone's camera to capture imagery of their surroundings, and GRL software matches that horizon against a localized database right there on the device to pinpoint their exact location. And they were able to test this out recently at Fort Bliss, and using this technology, those soldiers were able to figure out their position without losing a drop of a GPS signal. So in a denied environment, that's pretty outstanding.
That is amazing.
Yeah. And I think they're also trying to integrate with CHL right now to look at Army watercraft and allowing ships to navigate simply by reading shoreline features using that technology. So to sum it up, GRL is trying to work ground, sea, and air, I think, at some point to defeat that GPS jamming, and they're using it with native sensors, so like cameras that are already on soldiers and vehicles, and that's solving a massive tactical problem without adding additional cost or weight to the mission.
Wow, that's great. So, okay, transitioning to civil works, what kind of technology does GRL have that improves disaster response?
One of the cool things about working in the science and technology space is that many of the technologies that we develop for one type of application are useful for another, and the expertise that we develop doing one application can apply to other kinds of problems as well. So one example of that is we have some really great talented research staff that develop new ways to perform battle damage assessment and look at how physical structure changes, on the landscape as, it's attacked or is degraded in some other way. And when we think about civil works, the Army's often, or the Corps of Engineers rather, is often activated, to provide engineering support services in times of crisis and after natural disasters. And so our, research staff were able to, pretty rapidly adapt many of those same approaches to understanding battle damage, to understanding, what structures might be damaged, by hurricanes or wildfires, and, the differences in the debris that's created, because the Corps of Engineers is often, asked to respond to a national debris mission of some type. And so it's also kind of interesting, right, that debris is not the same depending on the natural disaster that may have caused it. So, in a wildfire, those structures are burning, and so you have ash piles, and that's a very different type of debris than perhaps in a hurricane, where maybe you had a flood and you just have these, piles of just stuff,
right.
That, maybe hasn't burned, right? And so it's a bit different. But we were able to, work with our other Corps of Engineers partners, our FEMA partners, in response to some of the recent wildfires in the past, the ones in Maui, the ones in Los Angeles. We were able to rapidly support the Corps when Hurricane Helene hit and affected the southern Appalachians and had all the flooding and all the terrible damage that happened there. To be able to provide a map and some type of assessment very quickly, especially in areas where roads were washed out and data availability might not be great, and people are just trying to get a sense of what happened, to then figure out, okay, well, now that we know what happened, what does that mean that we need to do, and how can we recover from these kinds of tragedies. So I think when we kind of look across GRL, there's other places where we've added value for the civil works as well. If using remote sensing technologies to understand vegetation health and inform environmental restoration activities and those kinds of things, or advancing technologies that are helpful to mapping bathymetry with or topography with different types of LiDAR technology. So, the way that works is, light is emitted, it bounces off surface and is received again. And through that, you can build up these sort of 3D models and 3D maps. And so, there's all kinds of, or digital twins is another one,
right,
using, technologies to map the insides of structures, the outside of structures. Those can be used to understand how those structures behave, or if they may be failing, or we can sort of virtually, improve them through modeling and simulation before we ever go make a physical real-world modification, and go through those processes. That it buys down a lot of risk, and over time. So, there's certainly so many ways I think that the technology has value, both on the warfighting side and in support of the nation here on the homeland as well.
Absolutely. And so engineering a secure and resilient future is another central focus of our show this season. What does the concept of resiliency mean in your lab, and how important is that to your research?
Yeah, it's a really great question. Actually, Austin and I talked last week about this question and how important it is, but also what it means to us. And, resiliency is definitely about anticipating that disruption and building a system that can bounce back from it or keep operating, no matter what's thrown at it. And a real world example of this at GRL is a digital buoy system developed and patented right here by one of our own computer scientists, Mr. Alex Lee. And
he's been on the show before.
Yes. Alex is great. And what his work has done is so fascinating. So right now, the U.S. Coast Guard and the Corps of Engineers maintain over 12,000 physical buoys across our inland waterways, and they basically act as street signs and stoplights for our rivers. But in the real world, rivers flood, currents drag, buoys drift. So when a buoy drifts, navigation becomes pretty dangerous, and finding and resetting them can be slow and pretty costly. And that's where GRL's digital buoy technology has come in. So by integrating a smart sensor with a low bandwidth communication directly onto the buoy, we've been able to create a self-reporting mesh network. So for example, if a buoy drifts off course, it automatically alerts land-based monitors in real time so it can be corrected. Another one is if a river condition changes suddenly, we can push an emergency chart update and safety notices directly onto the local mariners right through the buoy network. So I'd say that's a pretty good definition of resiliency, taking an age-old physical infrastructure and turning it into a smart, rugged aspect with a secure communication web. And I think working from the ground up with our engineering aspects is what's been resilient.
Perfect. That's exactly what we needed to know. So GRL utilizes some incredibly advanced technology like LiDAR and the Geospatial Imaging Laboratory. How does this highly specialized technical expertise help ERDC as a whole tackle problems that others cannot?
Yeah, so I guess if we think about 3D, I think many folks, if they've used, Google Earth or many of the other products out there that, can show, the 3D buildings in a city maybe, and the, satellite imagery might be draped on top of it. That's what we tend to refer to as 2.5D mapping, whereas full 3D is not only that sort of exterior shell, but it's all, like if you imagine a skyscraper, it's all the interior rooms and, all of the 3D aspects of that building, and maybe utility infrastructure, and is there a subway tunnel underneath it, and is there a tree in the atrium? It's really having that complete picture. And LiDAR is a great way to collect a lot of 3D data. It certainly, small robots and things or handheld devices can be used inside structures to map those spaces. But outside a structure, either from drones or airplanes or other platforms can collect LiDAR. But traditionally, LiDAR collection, airborne LiDAR collection, you have an airplane that basically flies directly over what you're trying to map, and it's fairly slow-moving airplane that flies at a fairly low altitude, and using that type of technology in a dangerous situation or a conflict zone is not, particularly, survivable idea. And so what we've really pioneered with many of the great researchers here is extending that standoff dramatically and pushing the limits of long standoff LiDAR collection, and being able to create space between a hazard and how we are collecting that data and how we're developing that map, which provides a lot of options
Right.
for the Army to use. And there'll probably be a really cool demo here in the next year or so where we get some of those that new capability sort of showcased in a very high altitude launch that we're very excited about in demonstration. But for the Geospatial Imaging Lab itself, so if you're going to be in the LiDAR business, and we're in the LiDAR space, and we work with a variety of partners, and those partners come to us, industry partners, other federal partners. They come to us for our team's expertise in image formation at distance. It's hard to do, especially with some of the fairly exquisite technologies that we're using. But we needed a space where that team could really thrive, and so they previously were working in this very small optics lab. It was a tiny little, almost like a closet, basically, and now they have a fairly large room with several optics benches and lots of different devices, and they have mission partners, in the space right next door to them, so they're easily able to, interact with, other, key personnel that work in that space, and advance the technology together, as a group, not just, GRL doing its own thing, but as part of a broader effort.
Okay.
Yeah, so I think, that's really
That's the sum of it, right?
Of that facility, yeah.
Yeah. Awesome. So, okay, looking ahead, are there any key takeaways that you want our listeners to understand about the importance of the work being done at GRL?
Yeah, so I'll go first on this one. I think if I have to boil it down, I would just want them to know, what we do is critical to both national security, but also our everyday lives. And what we do is not exclusively about overseas conflict. And Austin already touched on this, but the same spatial analysis and 3D mapping technology that protects our warfighters is also actively, being used here at home to guide emergency response and civil infrastructure projects. So ultimately, I think GRL is directly adding an immense amount of value both to the warfighter and to our nation. And I feel really lucky that I get to work here and get to work alongside these awesome researchers that, make our world a safer, better place.
Awesome. Austin?
Yeah, and I would add, I really think we're about empowering people. We're about empowering soldiers to understand more about the world that they're asked to do a mission in. And
Right.
we're about empowering the scientists that work in our organization, the engineers that work in our organization to really pioneer new technology and advance the state of the art and figure out what the next art of the possible is really going to look like, and use that to help our Army be more lethal, be safer in how it conducts its activities, but also solve really hard problems that the nation faces here in the homeland. I think that's really where the true value, I think, of the ERDC, where it lies, is collectively across the 7 labs, not just at GRL, but is our ability to empower people to make an impact and make a difference.
Well, you just said a very impactful statement, because this was the last show of this season. So that being said, that was just a great way to sum up this season and actually what ERDC is about. So thank you for that. And also thank you guys for what you do to protect our nation. It is so super important, and people are learning more and more about that. So thank you, Austin, and thank you, Sarah, for being on the show today.
Thank you so much.
Thank you. And thank you for listening to Beyond the Gates. Be sure to tune in next week for a very educational show about ERDC. Have a great day.